Okay, good morning. It's Professor David J. De Los Reyes. Okay, the date for today is November 7, 2023, and the time is what time? 1:26 a.m. Okay, my topic for this morning will be a continuation of my easy machines, and I am now on the study of alternators. So, alternators, this will now be lesson number 54. And the title of the topic is actually Alternator Prime Movers. Okay, let's proceed. The subject matter for this morning will be a continuation of my long video format topic, AC machines, and this is now lesson number 54. And the title of the topic is Alternator Prime Movers. The last time around, I discussed the concept of power generation by using an alternator and the requirements to generate an alternating current is actually there should be a conductor and the magnetic flux, and the magnetic flux and conductor should have an interaction to produce an alternating current. So for tonight I will be discussing how an alternator produce alternating current, and the other requirement is that there must be a prime mover, the one that will rotate the armature. Okay, let's continue. The three prime movers of big alternators. The number one is for small alternators. For number two and number three are actually the big ones. These are actually the prime movers of our voltage sources. Okay, comprising of how many, what do you call this, states maybe. One power generator will be supplying a 2 states or 3 states, something like that. But it will be in combination of some steam power plant and hydropower plant, or plus the other thing is the so-called like here in the USA there is the so-called nuclear power plant. Okay, let's proceed. For the small alternators, the prime movers are actually internal combustion engines like the engines of our cars and SUVs. Those are internal combustion engines. Okay, the what do you call this, the fuel needed to rotate those internal combustion engines like our cars are actually gasoline or diesel. So if the alternator is only maybe for a small community, okay, we could make alternating current, and the prime mover for that one could be a diesel engine or a diesel engine. The power output is not so big if the prime mover are only diesel engine and gasoline engine, because diesel engine and gasoline are actually very expensive, like right now. So if you try to generate alternating current by using diesel and gasoline, maybe the what do you call this, the output power in which that will go to the powerhouses, maybe the expenses might be too much in comparison to the what do you call this, to the size of the alternator itself. So it's not an economical way to generate power if we are talking of big areas like maybe 3 states or 2 states, right? So for small alternators that only power up maybe not so many houses, the prime mover could be a diesel engine or a gasoline engine. So just make sure that you must have a stock of diesel and gasoline, okay, to burn and to rotate that alternator to produce alternating current. The bigger ones, which are actually the one we are using now here in the USA, in other parts of the world, are actually the steam turbine and the hydro turbine. The prime mover is actually a turbine. Okay? It is directly coupled to the alternator. Okay? Because to rotate the alternator, the prime mover should be a steam turbine. Okay? So, if the coverage area for a utility company is very big, of course, uh, they might be using heated water or nuclear reactor. Okay, so this is actually a long-term power source. The prime mover is actually a steam turbine, and steam turbine is actually uses heated water. Uh, it's just like you got a boiler here, boiler. This is now thermodynamics. Then you try to heat up this one, burn this one. So when this one, what do you call this, try to heat up, okay, it will, the heated water will expand, then try to operate the prime mover, and the prime mover is actually the turbine. Okay, the exhaust of this is actually fed to the turbine, so when the turbine rotates, and since the turbine is actually directly coupled to the alternator, when the turbine rotates, the alternator rotates. Okay, there is winding on the alternator, and the exciter is also flux, so there should be flux. So there's now the so-called requirement for power generation, flux, okay, and winding, and we got movement, so we will produce an alternating current here, right? So this is just a block diagram of set up of power generation. This is the alternator, it got windings. This is the prime mover. The prime mover for number 2 is a steam turbine. It's the turbine rotates due to the heated water. That's why it uses heated water. Okay. For the heated water, for it to be economical, if you just use diesel or gasoline, it's very expensive. So to be more economical, better use nuclear. Right? Or we could use bunker oil, but bunker oil actually pollutes our sky. That's why we got the global warming. So I think there are still some countries which use bunker oil in the heating of the steam turbine. But the better way to generate heat to activate this turbine is by using nuclear reactor. Okay. What will be number 3? Number 3 is hydroturbine. Because there are 2 types of turbine. The turbine that is activated by using heated water. And there is a turbine, okay, that also rotates, but instead of heated water, it is live water. Live water. And this live water actually emanates from dams. Okay, it is something like this. It could be the Colorado River, maybe, where is the source of a big body of water. So if we try to circle, what you call this, capture this water by using as what you call this big cement foundation over here with this spillway, okay, and underneath this one is actually we got the so-called penstock. So water goes in here. Then this penstock is actually a big pipe which is directly fed to the turbine, the live water turbine. Okay, and this water turbine is directly connected to the alternator. So as long as there is water, okay, entering the penstock, the turbine will rotate. Okay, when the turbine rotates, the alternator rotates, and when the alternator rotates, it generates power. That's why we got electricity at home. So for as long as there is water in the dam, we got electricity. That's why we got problem with brownouts or blackouts sometimes, because the level of water on the dam is actually very low. So if the level of water on the dam is actually very low, of course the pressure on the penstock is also very low. There's not so much what they call this rotation on the turbine. So if we decrease the revolutions of the turbine, of course, the alternator will also decrease in the power generated. But in here, for as long as there is water, we could generate alternating current. That is for body of water, which is lime, for hydro turbine, right? Or this number 2 here, to heat the water, we use a nuclear reactor. Okay? These are just the symbol for nuclear reactor, what you call this, uh, containment, right? This is where the, what you call this, exhaust will come out, right? And this is usually very near some water sources because nuclear reactor needs some cooling, what do you call this, element, just to, for the efficiency to be very good, you know. Because if nuclear reactor heats up, there's a problem. So actually, nuclear reactors are actually mostly built near water supplies, near seasides maybe. Okay, so these are the prime movers of alternators. So for small alternators, it could be an internal combustion engine, and this internal combustion engine, it could either be a diesel engine or a gasoline engine. The problem here is that diesel and gasoline are they're expensive, so if you keep generating electricity using diesel and gasoline, okay, we are in trouble. That's why there are other sources of power generation, and that is by using a steam turbine and by using a hydro turbine. For the steam turbine, for us to be economical, we use nuclear. We could use bunker oil, but since bunker oil pollutes the atmosphere, okay, there is a problem with bunker oil. For hydro turbine, we just use live water. So engineers before try to encircle some big bodies of water, then they try to put a big pipe over there that goes to the turbine. So when water goes to the big pipe, okay, the turbine rotates, so the alternator rotates, and we could produce electricity. Okay, that's it, guys. Those are the prime movers of alternators in real life: internal combustion engine, steam turbine, and hydro turbine. Okay, good evening from, or good morning from Los Angeles, Professor David J.